Friends, so today we can discuss this question from AtCoder Beginner Contest 162. Problem D, RGB triplets. So in this question you are given that there's a string of length n consisting of only alphabets R, G and B, and you have to find out the number of triplets I, J and K such that the triplet should satisfy these two conditions. Okay. So the conditions are SI, the ith character is not equal to the jth character, ith character is not equal to the kth character, and the jth character is not equal to kth character. So you have to find out a triplet, and this just means that you have to take RGB as a triplet. You cannot take RRG or something like that. You have to take RGB in any order, but RGB has to be taken as a triplet only, and J of I is not equal to K minus J. J minus I is not equal to K minus J, which actually means that the difference between the J and I index should not be equal to the difference between the J minus K index. Okay. So if you can see in this example, if I take I to be this and J to be this and K to be this, it is satisfying the first condition because we are taking RGB, and also the difference between these two, if we take the indexing 0, 1, 2, 3, the difference between them is 2 and the difference between them is 1. So it's satisfying, the answer is 1. But if I take this as R, though it is also RGB, but the thing is the difference between them is 1. So this is not possible. So the answer is only 1. So I hope you understand. The only triplet is 1, 3, 4. This 1, 3 and 4. Okay. So though it seems like you cannot do it manually or like in a brute force way, but the constraints are very small. The constraints, yeah, 4000, and you can't do it in O of n square. So how you can do it in O of n square? So you can iterate, because you know the value of I and j. For every value of I and j, you can check whether this K is an RGB or not. So what I mean it is, because you can first calculate how many R, G and B's are there in this whole string. So in this string, the total of 2 R's, 1 G and 1 B. Okay. So how many RGB triplets can you take in total without considering this statement? How many total RGB triplets can you take? You can take 2R, 1G and 1B, and you can also interchange these positions. So there are answer is 2. So what is I'm writing here? The thing is, because you have to take a triplet, so there are 3 positions. You can fill it with R, G or B. If you fill it with R, there are 2 possibilities of R. Then there are 2 possibilities. You can fill it either with G or with B. So if you fill it with G, the rest one is B, and you just have to multiply them. If you interchange also their positions, like put R here and G here, the answer would be same. So the answer is there maximum of 2 RGBs present, as you can see, RGB, RGB. But if any one of them is invalid, the invalid will only be which is not following this condition. So you can write here J minus I is not equal to J minus I is not equal to K minus J. Okay, so for finding K, just take J on the LHS. It's become 2J minus I not equal to K. So if K is not equal to this, so if K become equal to this, we just have to check, because we know the value of I and J, we will iterate over the value of I and J, and if K is equal to this, we will just subtract it from the total value, because this RGB also exists and we have also counted it, because we are counting it for the whole. But if it exists, we can subtract it from the total value. I hope you understand what the logic is. So let's code it. So let's code it. So what we are given in the input is n and the string, and the string only consists of RGB only. So what we can first do is make three variables R, G, B, iterate over the length of the string, and if s of I is equal to R, R plus plus, equal to G, G plus plus, if s of I is equal to B, B plus plus. Okay, so it tells us the frequencies of RGB in the total string, then the total number of triplets, total possibilities without regarding the second conditions are R into G into B. Okay, so now in the end we have to check whether there is a key which holds that the last condition is not true for the last k. So what we can do is we can make a variable RGB and make its value equal to the integer values of R, G and B. So why I'm doing this, you will see later in the code. Okay, so now we will iterate over the length from 0 till n, and then for j equal to I plus 1, j is less than n, j plus plus. Okay, so now we are iterating over every value of the string from I equal to 0 to n and j equal to I plus 1 to n, and what we can do is we will find the value of k for such I and j, and the k can be 2 into j minus I, which is this. Okay, so we can check if this k exists because we have taken total RGBs ever possible, and if this k also present, we will subtract it from the total answer because we do not want this k to be present. I hope you understand. Okay, so now we want to check whether this triplet with I equal to this, j equal to this and k equal to this exist to be RGB. So we can either check like R, this s of I is not equal to s of j is not equal to s of k, s of k is not equal to s of I. That can also be done, but a simple way is we have store all the value of RGB in the numerical form, and then because if all RGB are present, its sum is also the same. So what we can do is we can again do the sum of the ith character, the jth character and the kth character because it's inbound, and if it's equal to RGB we will do a total minus minus. After this we'll just do a cout of total because we have now removed all the triplets which are taken in account in the first place but are not following the second condition. You can run this also and check. answer is 1. Okay, fine. So it's accepted. I hope you understand the logic, how we do this question. If you still have any doubts, please mention down. Thank you for watching this video and see you in the next one.